Okay, picture this. You walk into a huge tech interview, and they hit you with a massive challenge. Design a global giant like SHEIN, completely from scratch. We're talking millions of users, insane flash sales, a product catalog that never ends. That's exactly what we're going to tackle. So, where would you even start?
So, here it is, the core of the problem. Over 100 million shoppers every single day. That number is just staggering. Where do you begin? This isn't just about writing some code. It's all about architecture, about scale, and about making the right trade-offs right from the get-go.
Here's our game plan. First, we're going to ask the right questions to figure out what we're actually building. Then, we'll sketch out the blueprint. After that, we'll assemble the main pieces, tackle the single hardest problem, a flash sale, and finally, put it all together to show off our final architecture.
All right, first rule of any big design interview, you have to resist the urge to immediately start drawing boxes and arrows. The most critical step, always, is to clarify what you're being asked. You've got to be a detective and figure out the real problem before you even think about a solution. So, the very first question for our interviewer has to be this: who are we building for? Are we just making the shiny app that shoppers like you and me use on our phones? Or are we also responsible for the massive, complex back-end systems for all the suppliers and the internal logistics teams? Because let me tell you, the entire scope of this project hinges on that one answer. Next up, we gotta talk numbers. Is all this traffic coming from one country, or are we dealing with a truly global audience? And here's a really subtle but incredibly important question. How perfect, down to the millisecond, does our inventory count need to be? Does it really matter if someone sees an item is in stock, but the last one was actually sold a fraction of a second ago?
And that leads us to the ultimate tug of war in any huge distributed system. What matters more? Do we want the app to be always online, always fast, even if some of the data is a tiny bit stale? That's high availability. Or do we need every single user, everywhere in the world, to see the exact same data at the exact same time with zero room for error? That's strong consistency. Because at this scale, trust me, you can't have 100% of both.
And we have our answer. The interviewer gives us our marching orders. We need to focus on the consumer-facing app. It's gotta work for a global audience. And this is the kicker, it's totally fine for things like product pages or even inventory counts to be a little out of sync. We call that eventual consistency. But there's one huge exception: money. Payments have to be perfectly, absolutely consistent.
Perfect. Now that we actually know what we're supposed to be building, we can move on to step 2, drawing up the blueprint. This is where we turn that mission statement into a real list of what the system needs to do. So functionally, we have to get the basics absolutely right. The journey for a user has to be buttery smooth, from searching for a cool jacket to looking at the details, adding it to the cart, paying for it, and then tracking the package. You mess up any one of those steps, and the whole experience just crumbles. These are the non-negotiables. Now, this really spells out that critical trade-off we just made. For almost everything on the site, looking at products, reading reviews, getting recommendations, we are choosing high availability. We'd much rather the site be fast and always up than be perfectly up to the second. But the second you're dealing with a credit card, bam, we flip the switch. We demand strong consistency. So what the heck does eventual consistency actually mean? Well, think of it like global gossip. When a new piece of information comes out, it takes a little bit of time to spread to everyone around the world. But if things quiet down for a second, eventually everyone will end up hearing the same correct story. It's that tiny, acceptable delay that makes massive systems like SHEIN or Netflix feel so responsive. Okay, blueprint is in hand. Now it's time for the fun part, step 3. We're going to start putting the big pieces together and sketch out what this thing actually looks like at a high level. Let's follow a request from your phone all the way to our servers and back again. So the flow is pretty standard for a modern app. A request starts on your phone or computer. The first thing it does is hit a CDN, a content delivery network, which quickly serves up all the heavy stuff, like images and videos from a server near you. Then the request goes through an API gateway. Think of it like a traffic cop for our whole system, before it finally gets to the brains of the operation, our backend services. And that backend is not one giant blob of code. Nope. We're using a microservices approach. It's kind of like building with Legos. We have one service that only handles user accounts, another one only handles the product catalog, another one for search, and so on. This is so crucial because it means we can scale, update, or fix each piece independently without taking the whole site down. And just like we use different services, we need to use different databases. There's no single tool that's right for every job. For our gigantic, messy, ever-changing product catalog, a flexible, no SQL database is perfect. For our orders and payments, where every transaction has to be perfect, we need the rock-solid guarantees of a traditional relational database. And for search, we bring in a specialist built for one thing: pure, blazing speed.
Okay, so we've built the foundation. It looks good. It seems stable. But can it handle the ultimate stress test? Step 4 is where we face the music. It's time to figure out how to survive a flash sale, that moment when your traffic doesn't just increase, it explodes.
And I'm not talking about things getting a little busier. During a flash sale, you can expect traffic to be 10 times higher than normal, or even more. This isn't just a big wave hiding the beach. This is a full-blown tsunami that can vaporize a poorly designed system in seconds. This is the multi-million-dollar question right here. You have 10,000 units of some super popular item. 1 million people click buy at the exact same instant. How in the world do you make sure you only sell 10,000 and don't create 990,000 angry customers? It's a classic problem, but at a scale that's just mind-boggling. And here is the absolutely elegant solution. We don't hammer our main, slow database 1 million times a second. Instead, when you add an item to your cart, we just make a little temporary note in a super fast cache. This note reserves the item for you for about 15 minutes. We only go back and officially remove it from the main inventory after your payment successfully goes through. If you leave or your card gets declined, the reservation just disappears. It's simple, and it saves our database from a total meltdown. So let's just recap our flash sale playbook. For every major threat, we have a specific countermove. The massive traffic spikes, we handle those with caching. The risk of overselling, that's what a reservation system is for. To keep the database from catching fire, we use queues to process orders in an orderly fashion. It's a full-on strategy to defend our system. And with that, we've survived the storm. We figured out the problem, we designed all the pieces, and we solved the absolute hardest challenge they could throw at us. All that's left is to put it all together and present our final architecture with a strong, confident summary. So, to wrap it all up in a nutshell, we designed a globally distributed e-commerce system that is mostly used for browsing. Its biggest challenges are keeping the inventory count right and making sure the app feels fast. We solved those problems using a multi-layered defense, aggressive caching, our clever reservation-based inventory system, and handling tasks asynchronously in the background. And through it all, we made sure the one thing that has to be perfect: payments is always strongly consistent. It's a powerful blueprint, and it really makes you wonder, doesn't it? How many other massive apps that you use every single day are built on these exact same principles?